Hello guys, today I'm going to show my assignment link of the code that can show the smart system model. So my model is based on the temperature and the energy consumption. So we know that the relationship between the temperature and energy consumption is very stable because in your room, if the temperature increases, so you may use some kind like the air conditioner to generate heat. Even if you want to generate cold, you still need to use the air conditioner. And the air conditioner is a very important, or I say it's a very important ingredient that we need to consider in energy consumption cost. So let's see this. So first, we need to import three libraries because the NumPy can do those the calculation work, and the matplotlib, and also the sklearn. We use these two to generate images and some other sorts of calculations. And it's very inconvenient models, but we need to install them on our device before we run this code. Okay, so actually, I didn't use the dataset on website. I create my own dataset to show it. So we can see like that. The temperature is here. Each to show the trend. So I set all the temperature value according to the increased trend. We can see that it increases gradually. And its corresponding data set is here. Name it its cost because it shows the energy consumption. We can see like that. So it means that for like this 10.3 degrees in Celsius. So its corresponding energy consumption in that temperature is 2570 euro. The unit is euro. Well, this one, the unit is degrees in Celsius. Okay, so yeah, to show it, I print something like the input temperatures, then we can show the whole temperature and use the flatten to be shown on them. We will see this later. And I also want to show the actual cost because I'm sorry, because the actual cost actually is the cost that I would say it is the value of the data that we can compare with the predicted one because we know that there's some error in the predict data, of course, because there are lots of nonlinear factors we haven't considered yet, because the whole model of this code is linear regression. So I can build a model is an object. They name it as a linear regression because the whole model, I use linear regression to calculate the predict data. So this and then use the function fit. This is a very useful function because it can automatically find the suitable predict line because we know that the basic form of the linear function is very simple. We just need a slope and intercept, where the fit can ultimately find the suitable parameters for us. Yeah, to show the slope, yeah, to show the equation, I said that it can show the slope. The A is the slope, the B is the intercept to us. Then print this one. The energy cost is like that to show the equation form, because it can be more clear for users to see. When we can use a predict function to predict the whole temperature and predict, and then it can print, I mean, it can output all the predicted data of the energy consumption, the energy cost, or I say the energy costs. Well, we can use the scatter plot and to show off them. Well, as because we need to show the figure that I set that to make it more clear. I use that's just like we input those libraries. We can then give them a title, the X label and the Y label, because they have different axes to show, and we can show it. Okay, so we'll just like see it because due to the whole model is a linear regression. So just like I mentioned before, there's some over prediction error and some under prediction error compared with the actual data. The predict data may be some errors, but I think it's acceptable because just like I said, there are lots of factors we haven't considered yet. This is just linear regression, a very simple one. But the nonlinear factors, maybe the sudden increase of the the electricity fee should be considered maybe in the future. Yeah. So let's just see what the code, how the code output. Yeah, just like it output, we can see it. So we can see those data here. This one, these two set of data is the data set as set. Well, this one is the predicted data. So the model train with this data set and then get these output like it is said. Of course, there's no accurate one. Yeah, we can compare it according to this. This chart can show it more accurately. We can see there are some arrows. Well, the biggest one may be this, but we can see almost, if we see it more clear, we can see it almost everyone is near the predict line. The actual data and the predict data is not accurate, but much similar, I think. So it is acceptable. Yeah, that's it, or how it works. Okay, so that's all. Thank you, guys.